Okay guys, so we are now jumping into another day of verifying trig identities. So we're continuing yesterday's lesson. Remember to have your trig identity reference sheet available because we will be referencing it multiple times in every problem. Okay, so remember our game plan here was to always focus on the more complicated side first. Remember what we're trying to do when we verify is prove that these two things are equal. And we do that by rewriting one side with our trig identities until it looks exactly like the other side. So I'm going to rewrite this side because it looks a little more complicated. And the way I'm going to do it is I'm going to focus in on trying to get to sine squared and 1. So I think the first thing I want to do is rewrite everything so I have some sines in there. Okay, so I know I can rewrite cosecant squared as 1 over sine squared, right? And cotangent squared is the same thing as cosine squared over sine squared, right? So the first thing I did, I decided to do that. That was my reciprocal identity and my quotient identity because I know my answer contains just a sine, so I want to rewrite everything with sine. But it looks like I still have a bunch going on. So what I want to do is I want to get this so I'm dealing with less, junk. So I'm going to try and rewrite both these guys so they're just a single fraction. So this guy, I would have to get a common denominator. I would have to rethink of that 1 as sine squared over sine squared, right? It's easy to get a common denominator when you're dealing with 1. So that's what my new numerator looks like. It looks pretty busy, but it'll simplify down soon. And then down below, I'm actually going to do the same thing because my denominator down below is also sine squared. Right, so I have something like that. Right, and now, next step I'm going to do is now that I have these common denominators, I can actually just go ahead and do some work to make everything look a little prettier. I combine this guy into a single fraction down below. I can also combine to a single fraction. So I got something like that. And then you'll see there's a few steps we can take here, right? Sine squared plus cosine squared, isn't that actually just equal to 1? So my denominator just got cleaned up quite a bit. Right? And then to finish off, I'm dividing two terms here. And what I'm going to do is I'm going to go ahead and do my little keep change flip that I've done in the past, which remember looks like this. I'm going to do sine squared plus 1 over sine squared. And then I'm going to actually multiply now instead of divide, and I'm going to do sine squared over 1. So I did a little keep change flip there. Okay. And now if you look at what we're dealing with here, sine squared and sine squared are going to cancel, right? And we're going to have sine squared plus 1, and you should notice that is exactly what we were looking for. Addition is commutative, so we can easily, if you want to just, for the sake of it, switch those guys are equal to each other. So we have gotten to our goal there. Okay, so for number 8, the side that looks a lot more complicated to me is this right side. We're trying to get all this stuff down to sine and cosine. So the first thing I'm going to do, because I know I want to get to sine and cosine, I'm going to rewrite all this as much as possible with just sine and cosine. Secant is 1 over cosine, right? Cosecant is 1 over sine, so I'm using the reciprocal identity on both those. And then down below with tangent and cotangent, I can use the quotient identity on both those guys. And I get something like that. So this one's looking pretty similar to number 7. All right, so first off, what we have to do is we're going to have to try and get these guys to be single fractions so we can simplify them down a little bit more. So up top, this guy would need sine, right? Because if you look at it, our denominators are cosine and sine. If we get sine on this side and cosine on this side, they'll have a common denominator. So that's going to look something like this. I'm going to have sine of u over here, and I'm going to do a couple steps in one just so we still have room here. But it's going to be sine of u and then plus cosine of u over cosine of u, sine of u. Yep. So that's my new numerator, and all I did to get that, I multiplied this guy by sine over sine, this guy by cosine over cosine. And then with my denominator, I'm going to do a similar deal. This fraction right here needs a sine, right? This guy's going to need a cosine for them to meet up with that denominator there. And that's going to give me sine squared plus cosine squared over cosine of u, sine of u. Okay, so it looks nasty right now, but at this point you should notice these few things. One, this guy right here, sine squared plus cosine squared, that is equal to 1 using our Pythagorean identity. So I'm going to rewrite this guy as something like this, 1 over cosine u, sine of u. And then the next step, I'm going to do that keep change flip that we did in number 7 as well. So I'm going to have sine of u plus cosine of u over cosine u, sine of u. And now I'm going to do multiplication, and I'm going to flip this guy. And what you'll notice is cosine of u, sine of u is on top and bottom, so those are going to cancel. And we have what we were trying to get to, which was sine of u times cosine of u. Okay, so for number 9, we've really got to be clever here. So I'm going to go ahead with this guy and consider that to be our more complicated side. Okay? So we're going to try and get from here to here. Okay? So right off the bat, there's not much we can do to simplify down. Okay? So what I would do to start here is I would actually try and get this guy so that we get rid of the denominator nastiness that we have going on now. Okay? And the way we would actually do that is we can go ahead and use 1 plus cosine of a. Okay, the reason I chose 1 plus cosine of a is not because it was in the numerator, but because it's the opposite of 1 minus cosine of a right here. Okay, so if we do that, these two guys, when we multiply them, those guys are going to be creating a difference of 2 squares opportunity there. Okay, so all I have to do here is multiply 1 minus cosine times 1 plus cosine. And just for your guys' sake, we'll do a little side work on each of these. So I'm going to do 1 minus cosine times 1 plus cosine, and I'm going to FOIL it. 1, I got plus cosine of a, minus cosine of a, and minus cosine squared of a. And check it out, middle terms cancel. So my new denominator is going to be 1 minus cosine squared of a. Okay. And then up top in my numerator, I'm going to do some more side work here. So that's 1 plus cosine of a times 1 plus cosine of a. So I'm going to FOIL. It's going to be 1 plus cosine of a plus another cosine of a, and then also plus cosine squared of a. Okay, so when we check this guy out, we get 1 plus 2 cosine of a plus cosine squared of a. Okay, so that's what we could put up here, but at first glance, I'm thinking that looks a little too complicated. So what I'm going to do instead is go ahead and just write it as 1 plus cosine of a squared, because it's 1 plus cosine times 1 plus cosine. And let's see how we can move from here. 1 minus cosine squared of a, you should notice that as your Pythagorean identity rearranged. Remember, that's sine squared plus cosine squared equals 1. If we rearrange that guy, we can actually just go ahead and say that 1 minus cosine squared is equal to sine squared. Right? So what you'll notice is all of our guys here are now squared. Right? So sine is squared, this whole expression is squared. So I'm going to go ahead and I'm going to pull that square out in front of all this. Okay, so all I did right there is I had this squared as well, so I was like, hey, why not pull it out in front of everything? Right? And then to finish off, remember our goal is to get cosecant plus cotangent in parentheses squared. So I'm going to see if I can break this up so I can rewrite it with cosecant and cotangent. So the way I'm going to break it up, I have a denominator of sine for these guys. So I'm going to have one of them be 1 over sine of A, the other be cosine of A over sine of A. So I just broke up the 1 plus cosine and used the denominator for both those. And what you'll notice is 1 over sine, isn't that cosecant? And then cosine over sine is tangent. And sorry, I mean cotangent there. And then we have the squared on the outside, which is exactly what we were trying to find there. Okay, so we got one more for you. Okay, so number 10 here, okay, we have this crazy stuff on the left, and on the right, much more simple. So we're definitely going to start with the crazy complicated stuff first. Okay, so with this one, looks like our first goal is going to be to go ahead and get a common denominator. If you notice, the answer we're trying to get to doesn't have any plus or minuses in it, so we want to combine all these guys somehow. And the way we do that with fractions is get a common denominator. Okay? Our denominators are 1 minus cosine and sine. So this side would need sine, right? So I'm going to multiply the top and bottom of this equation by sine. So that's going to be sine squared over sine times 1 minus cosine. And this side over here needs a 1 minus cosine, right? If we're going to have a common denominator here. So up top, I'm going to have 1 minus cosine squared, right? If I multiply 1 minus cosine on both sides. And on the bottom, I'm going to have sine times 1 minus cosine. The whole reason we did that is to get that common denominator, which we now have. So up top, if you check out what we have here, we're going to have sine squared of y plus 1 minus cosine of y squared all over sine of y times 1 minus cosine of y. All right, so we got it into a single fraction, but it's still really messy. So what I'm going to do in this scenario is I can't make any moves. I can't cancel any of those signs or anything because of that addition. So I'm going to go ahead and multiply out 1 minus cosine of y squared and then see if that can help us. So if I do that, let's just do a little side work here. That's 1 minus cosine times 1 minus cosine. I FOIL it, I get 1 minus cosine of y minus another cosine of y, and then plus cosine squared. So that's going to be 1 minus 2 cosine of y plus cosine squared. All right, so let's go ahead and rewrite all that and see if it helps us at all. So I got sine squared, and then this whole expression right here, we just multiplied out on the side, is 1 minus 2 cosine of y plus cosine squared all over sine times 1 minus cosine. Right. So now let's see what we can do here. Okay. One thing I noticed is that I have a sine squared plus a cosine squared. Even though these guys are separate, remember addition is commutative. We can move things around when two things are being added together. So sine squared plus cosine squared using our Pythagorean identity is just going to be 1. So I'm going to add a 1 in there and take those guys out. So I got something like this right now. And then 1 plus 1, I'm going to go ahead and erase that and put 2. Okay, get a better eraser real quick. And remember, our end game is to get to 2 times cosecant of y. So let's see what we can do next. What I noticed up top is I have a GCF of 2. So if I pull that 2 out, I'm left with 1 minus cosine of y. And finally, it looks like we're able to cancel part of this fraction, right? 1 minus cosine over 1 minus cosine. So then to go ahead and finish off, all we got to do, 2 over the sine of y, using our reciprocal identity, is going to be 2 times 1 over sine of y is cosecant. And we got our answer. Right? So once again, remember, these can be tough, and it might take some trial and error, but start with that complicated side, try a few things, and remember to actually use the fact that you know what you're trying to get to. Right? So what I want you guys to do to practice for the homework, I want you to try out numbers 7 through 10. Okay? So